We are going to be looking at this quadratics all forms template. So this will be our first day. And what this is basically we're going to be translating different forms to another form. So go ahead and make sure you have this printed out, and then you will write and follow along, and then you'll have this for homework as well. So you'll have two that we're doing together, and then you'll just have two for homework. So in this first problem, we are given vertex form. So hopefully you watched the video before this where we looked at each of the different forms and it tells us why they're useful and the different properties that it gives us. So looking at vertex form, we could actually answer quite a bit of questions already. So I'll wait on the standard and factored form, but the first question is the parabola will open up or down. Well, what we're going to do is look at that a value. So since the a value is positive, that means it opens upwards. So I'm just going to circle up. The vertex is a minimum or maximum. So we'll go ahead and wait on that. There is a vertical stretch or compression. So anytime your a value is greater than 1, or the absolute value is greater than 1, it's a stretch. So you'll see numbers like 2, 3, or it could be -5. And anytime that a value, the absolute value, is between 0 and 1, it's a compression. So in this case, it's a stretch. Okay. The domain, I will give that. So the domain of all parabolas is all real numbers. So I'm going to draw that fancy R. Okay, we could definitely find the vertex. So the vertex is 1, -8. The axis of symmetry. So what that means, it's where if you divide the parabola in half, it will be symmetrical. So the axis of symmetry is always going to be x equals h. So I might even write that up here. X equals h is the axis of symmetry. So it's a line that divides the parabola in half. So h, remember, in your vertex, this is h, and that is k. So it will be x equals 1. Okay, identify the y-intercept, we'll wait on that, and then identify the x-intercept, we'll wait on that as well. So let's go ahead and put this in standard form. So I'm going to use this space down below. So to put it in standard form, we just need to multiply it out. So for example, I have 2. Because it's x minus 1 squared, what that really means is x minus 1 times x minus 1, and then I have this -8. So what we actually have to do, we want to multiply those x minus 1 times x minus 1 first, then we'll distribute the 2, and then we'll subtract the 8, okay? So this will become 2 times parentheses. I'm going to use distributive property. So x times x is x squared. X times -1 is -x. -1 times x is -x. And -1 times -1 is +1. And then I have that all -8. So I know those two combine to make -2x. Now I'm going to go ahead and distribute the 2. So when I distribute the 2, I get 2x squared minus 4x plus 2 minus 8. So my final answer will be y equals 2x squared minus 4x, and then you have 2 minus 8, which would be -6. So I'm going to go ahead and write that up here. So that is going to be my standard form. So 2x squared minus 4x minus 6. Okay, so now that we found standard form, we should know what our y-intercept is. So if you watched the last video, we learned that the y-intercept is this last number when it's in standard form. So in other words, -6. So the reason for that is if I plug in 0 for x, that will give me the y-intercept. So 2 times 0 squared is 0, minus 4 times 0 is 0, minus 6 would just be -6. So the y-intercept is 0, -6. All right, so we're getting more things filled out here. Now we need to find factored form. Well, now that we have standard form, to find factored form, you just have to factor it. So we're going to look at our standard form equation, which is 2x squared minus 4x minus 6. So going back to factoring, hopefully we remember that. Whenever you factor, step one is to take out the greatest common factor. So looking at all three terms, we can pull out a 2. So then we would get x squared minus 2x minus 3. From there, that's where you can make your box. So in the top left, we would put x squared. Bottom right, we would put negative 3. Then you can go to your diamond. So we have negative 3x squared, and then we take our middle value and put that on the bottom. So I need two numbers that multiply to negative 3x squared, but add to negative 2x. So that would be negative 3x and positive 1x. And then I fill those in the boxes, and then I come up with my edges. So I get x, x, negative 3, and 1. All right, so then when I factor it, I actually get 2 times x minus 3, x plus 1. Okay, so we'll go ahead and write that in. So 2 times x minus 3 times x plus 1. Well, now that I know my factors, I can find the x-intercepts. So remember, to find the x-intercepts, you just set each of those factors equal to 0. So in this case, if we were to solve, we would get 3 and negative 1. Remember, you always want to write it as an ordered pair. So 3, 0 and negative 1, 0. Okay, so we'll go ahead and start filling this out. So what we're going to do is we are going to write out our vertex. So we know our vertex is 1 and negative 8. So we're going to go ahead and plot that. I believe this goes a little bit off the graph, so I'm just going to go ahead and put a dot down there. All right, so from there, we're going to pick x values to the left and to the right of the vertex. We should remember that it will be symmetrical. So I'm going to pick a number that's less than 1, so maybe 0, and then a number that's even less than that, so negative 1. And I'm going to go ahead and skip that last one because we're only going to use 5 points. And then pick a number greater than 1, like 2, and then greater than 2, like 3. So what we're going to do is go ahead and plug in those numbers to the equation. The nice thing is you have 3 different equations to choose from. So you get to pick whichever one that you'd like. So I'm going to go ahead and use vertex form just because that's what we were given. So I'm going to plug in 0 because that's pretty easy. So the space in the middle is for you to show your work. So 2 times 0 minus 1 squared minus 8. So let's think about this. What this really is, it's 2 times, well, 0 minus 1 is negative 1. Negative 1 squared is 1. So 2 times 1, which is 2, minus 8 is negative 6. So we should know that if that is negative 6, then the other point has to be negative 6 because we know it's symmetrical. So then we're going to go ahead and put that on the graph. So we have 0, negative 6, and 2, negative 6. And then we'll go ahead and plug in another point. I'm going to plug in 3 over negative 1 just because it's a positive number. So we have 2 times 3 minus 1 squared minus 8. So 3 minus 1 is 2, and then you square that and you get 4. So it's 2 times 4, which is 8, minus 8, which is 0. So then that means this point also has to be 0 because we can see that it is symmetrical about that vertex. Okay, so we have 3, 0, and negative 1, 0. And guess what? That totally makes sense because if we remember, look at our x-intercepts. 3, 0, negative 1, 0. So some of you might have not even plugged them in because you already knew. So then we're going to go ahead and sketch our parabola. And then we're going to answer the questions. The range. So the range has to do with the y value of the vertex, which is this point right here. So in this case, the range is y is greater than or equal to -8. So we're going to write y is greater than or equal to -8. Okay, so the vertex is a minimum or maximum. So we want to look at that vertex. Is that the lowest point on the graph or the highest? In this case, it's the lowest. So we would say the vertex is a minimum. All right, so that is the first one. So we're going to go ahead and do this next one together. So same thing. Okay, so this time we were given standard form. So let's go ahead and answer the questions that we think we can. So this parabola will open up or down. So remember, for that, we just look at the a value. So since it's positive, it opens up, okay? We should kind of know now that the vertex, if it's opening up, it will be at the bottom, which will make it a minimum, okay? There is a vertical stretch or compression because it is 2 and it's greater than 1. It is a stretch. The domain, remember all parabolas, unless it's restricted, will have a domain of all real numbers. Identify the vertex. That is something that we don't have yet. Identify the axis of symmetry. Again, we don't have. The y-intercept we do have, because remember it's that last value of standard form. So it'd be 0, -2. And then identify the x-intercept. That we also don't have. So we're going to go ahead and factor this. We'll go ahead and factor it and we'll put it in factored form. So we'll go ahead and start with that. Okay, so we want to put this in factored form. Okay, so what we're going to be factoring is 2x squared minus 2. So this actually might be easier than you think. So remember, step 1 when you factor is to take out the greatest common factor. Well, in this case, we could pull out a 2, and then we get x squared minus 1. So we actually are only factoring that x squared minus 1. Now think back. This is a special case, which is called difference of squares. So this will factor to x plus 1 and x minus 1. And that's it. So factored form is 2 times x plus 1 and x minus 1. So because we have factored form, now we should be able to find the x-intercepts. So the x-intercepts are going to be -1, 0 and 1, 0. Okay, so next step is to find vertex form. Okay, so we want to put this in vertex form. So we spent 2 days on completing the square to put into vertex form. So we're going to go ahead and use that. So we have 2x squared. I'm going to go ahead and put plus 0x and then minus 2. So remember, when we complete the square, the a value, which is right here, has to be 1. Well, in this case, it's not. So we're going to go ahead and take out a 2. And we'll have to remember that we did that. So we get x squared, and then we will get plus 0x minus 1. Okay, so from here, I'm going to go ahead and set this equal to 0. So we'll get x squared plus 0x plus blank equals 1 plus blank. Okay, and again, this is completing the square to put into vertex form. So to get that blank, you take your middle term, which is 0, you divide by 2, and you square it. So 0 divided by 2 is 0, and 0 squared is 0. Okay, so because you put 0 there, you have to put 0 there. So again, we did 0 divided by 2, which is 0. I'm going to circle that number. and then you square it, and you get 0. So then remember, that is your factor, so you get x plus 0 squared equals 1. And then I'm going to go ahead and bring it over, x plus 0 squared minus 1. And then the last step is to multiply everything by 2, because we took out a 2. So it'll be y equals 2 times x plus 0 squared minus 2. All right, so that is our vertex form. So 2 times x plus 0 squared minus 2. So now we can answer the vertex. So the vertex is 0, negative 2, because we have vertex form. And then because we have the vertex, we can find the axis of symmetry, which is just always the x value of the vertex, which would be x equals 0. All right, so now we plug in points. So we know we're going to skip that and skip that. So for the vertex, it is 0, negative 2. So I'll go ahead and plot that. And then I'm going to pick 2 points higher and 2 points lower. Remember, you only need to really do one side, and then you can reflect it. So if I plug in 1, and I'm looking here, I'm going to plug it into standard form just because that's what we were given, but I could pick any. So 2 times 1 squared minus 2. Well, 1 squared is 1. So 2 times 1 is 2, minus 2 would be 0. So because that's 0, this is 0. So then I'll go ahead and plot that point and that point. And then I'm going to plug in 2. So 2 times 2 squared minus 2. Well, 2 squared is 4. 2 times 4 is 8. And 8 minus 2 is 6. So I have negative 2, 6. And I have 2, 6. And then I could connect them. Okay, so last thing is just the range. So the range is dealing with just this bottom point right there. So y has to be greater than or equal to negative 2. And that is quadratic all forms.